Question 1. Examination of the data shows that a critical dataset intended for performance analysis contains personally identifiable information, PI, that was not explicitly consented to for this specific analytical purpose, and the project deadline is rapidly approaching. The engineer has identified this potential privacy violation. Option A. Proceed with the analysis using the dataset as is, assuming the PII is necessary for accurate performance metrics and that the risk of exposure is minimal given internal access controls. Option B. Anonymize the dataset using a standard hashing algorithm without further investigation into the specific PII types or the effectiveness of the anonymization for this particular dataset. Option C. Proceed with the analysis but exclude the PII columns from the final output, hoping this mitigates the privacy concern without further consultation. Option D. Halt the analysis. Immediately escalate the PII discovery to the data governance team and legal counsel, and request guidance on how to proceed, including potential data anonymization or obtaining explicit consent. Correct answer is A. Proceed with the analysis using the dataset as is, assuming the PII is necessary for accurate performance metrics and that the risk of exposure is minimal given internal access controls. Explanation. This scenario presents a professional challenge due to the inherent tension between delivering a project on time and ensuring data privacy and ethical data handling practices. The big data engineer is privy to sensitive information that, if mishandled, could lead to significant reputational damage and legal repercussions for the organization. The pressure to meet deadlines is a common workplace reality, but it must not override fundamental ethical and regulatory obligations. The correct approach represents best professional practice because it prioritizes adherence to data privacy regulations and ethical guidelines by flagging the potential privacy issue and seeking clarification and remediation before proceeding. The engineer demonstrates a commitment to responsible data stewardship. This aligns with the principles of data minimization, purpose limitation, and the right to privacy, which are foundational in many data protection frameworks. Proactively addressing the issue prevents potential breaches and fosters trust with data subjects and stakeholders. An incorrect approach that involves proceeding without addressing the privacy concern is a direct violation of data protection principles and potentially specific regulations. This could lead to unauthorized access or disclosure of sensitive information, resulting in severe penalties, including fines and legal action. Another incorrect approach, such as anonymizing the data without fully understanding the anonymization's effectiveness or the original data's sensitivity, risks re-identification and still falls short of robust privacy protection. This demonstrates a superficial understanding of privacy controls and a failure to exercise due diligence. A third incorrect approach, which is to ignore the issue and hope it goes unnoticed, is negligent and unethical. It shows a disregard for professional responsibility and regulatory compliance, exposing the organization to significant risks. Professionals should employ a decision-making framework that begins with identifying potential ethical and regulatory conflicts. This involves understanding the data's sensitivity, the applicable laws and guidelines, and the potential impact of different actions. The next step is to consult relevant policies and seek guidance from legal or compliance departments when uncertainty arises. Prioritizing transparency and documentation of decisions and actions is crucial. Finally, advocating for ethical data handling practices, even under pressure, is a hallmark of professional integrity. Question 2. Performance analysis shows that a critical ETL extract, transform, load job processing large volumes of customer data is consistently exceeding its allocated runtime, impacting downstream reporting. The job involves complex data transformations and joins across multiple data sources. Which of the following approaches would be the most effective and professionally sound for optimizing this process? Option A. Implement a new, highly complex distributed processing framework for the entire ETL pipeline without prior benchmarking or pilot testing. Option B. Focus solely on optimizing the data extraction phase by parallelizing read operations, assuming that the transformation and load phases are already efficient. Option C. Immediately provision additional compute resources and increase the memory allocated to the processing cluster to handle the increased workload. Option D. Analyze the execution plan of the ETL job to identify specific query inefficiencies and optimize the data transformation logic and join strategies based on data distribution and cardinality. The correct answer is D. Analyze the execution plan of the ETL job to identify specific query inefficiencies and optimize the data transformation logic and join strategies based on data distribution and cardinality. Explanation. This scenario is professionally challenging because optimizing big data processes involves balancing performance gains with resource constraints, data integrity, and adherence to IBM's recommended practices for the C2090-101 exam scope. The pressure to deliver faster results can lead to shortcuts that compromise accuracy or introduce inefficiencies. Careful judgment is required to select optimization strategies that are both effective and sustainable within the given technological and operational context. The correct approach represents best professional practice because it focuses on understanding the root cause of performance bottlenecks through systematic analysis and applying targeted, data-driven optimizations. This aligns with IBM's emphasis on efficient data processing and the principles of process optimization, ensuring that improvements are measurable and contribute to overall system health. It demonstrates a commitment to robust engineering practices, which are implicitly expected in professional certifications like the C2090-101, by prioritizing a holistic understanding of the data pipeline before implementing changes. An incorrect approach that involves prematurely scaling hardware without identifying the specific performance bottleneck is professionally unacceptable. This represents a failure to adhere to sound engineering principles by treating symptoms rather than causes. Ethically, it can lead to unnecessary expenditure and resource waste, which is a form of professional negligence in resource management. Another incorrect approach, such as implementing complex unproven optimization techniques without thorough testing, risks introducing new issues, data corruption, or system instability. This violates the professional responsibility to ensure the reliability and integrity of data systems. A third incorrect approach, focusing solely on optimizing individual components in isolation without considering their impact on the overall data pipeline, demonstrates a lack of systemic thinking. This can lead to localized improvements that degrade overall performance or create new bottlenecks elsewhere, reflecting a failure in comprehensive process analysis. Professionals should use a decision-making framework that begins with clear problem definition and data collection. This involves profiling the existing system to identify specific areas of inefficiency. Next, potential solutions should be brainstormed, considering various optimization techniques relevant to big data processing. These solutions should then be evaluated based on their potential impact, feasibility, cost, and risk. The chosen solution should be implemented incrementally and rigorously tested, with performance metrics tracked before and after the change. Continuous monitoring and iterative refinement are key to ensuring sustained optimization and preventing the recurrence of performance issues. Question 3. System analysis indicates that a financial institution's real-time trading platform requires critical market data to be processed and made available for regulatory reporting within a strict 5-second latency window. The data volume is highly variable, with peak loads exceeding 100,000 events per second, which approach best balances the need for low latency with comprehensive data integrity and regulatory compliance for this scenario. Option A. Prioritize raw data ingestion speed by minimizing validation and cleansing steps in the initial processing stages, deferring data integrity checks to a later, less time-sensitive phase. Option B. Utilize a single, high-throughput batch processing framework to ingest and process all market data, relying on its inherent capabilities to meet reporting deadlines. Option C. Implement a hybrid processing architecture combining in-memory stream processing for initial data validation and transformation with scheduled batch processing for complex aggregations and historical data enrichment. Option D. Employ only real-time stream processing for all data, focusing on event-level processing without incorporating historical data or batch aggregations for reporting. The correct answer is C. Implement a hybrid processing architecture combining in-memory stream processing for initial data validation and transformation with scheduled batch processing for complex aggregations and historical data enrichment. Explanation. Scenario analysis. This scenario presents a common challenge in big data engineering, optimizing the processing of a large, continuously flowing data stream to meet stringent latency requirements for a critical financial reporting system. The challenge lies in balancing the need for rapid data ingestion and transformation with the imperative to maintain data integrity, accuracy, and compliance with financial regulations. Failure to meet latency targets can lead to delayed reporting, potential regulatory penalties, and loss of market confidence. The complexity is amplified by the dynamic nature of big data, where volume, velocity, and variety can fluctuate, requiring adaptive and robust optimization strategies. Correct approach analysis. The correct approach involves implementing a multi-stage processing pipeline that leverages both in-memory processing for immediate, low-latency transformations and batch processing for more complex, resource-intensive aggregations and enrichments. This hybrid strategy is best professional practice because it directly addresses the dual demands of speed and thoroughness. In-memory processing, e.g., using Apache Spark's in-memory capabilities, allows for rapid filtering, validation, and initial transformations of incoming data, ensuring that critical real-time metrics are available within the required latency. Batch processing, scheduled strategically, e.g., hourly or daily, can then ingest the processed real-time data along with historical data for more computationally expensive operations like complex aggregations, anomaly detection, and regulatory compliance checks. This approach aligns with regulatory expectations for accurate and timely financial reporting by ensuring that while initial data is processed quickly, comprehensive validation and reporting are still performed. It demonstrates a commitment to data governance and auditability, crucial for financial services. Incorrect approaches analysis. One incorrect approach is to exclusively rely on a single, high-throughput batch processing system for all data. This would likely fail to meet the strict latency requirements for real-time financial reporting, as batch jobs inherently introduce delays. From a regulatory perspective, this could be seen as a failure to implement adequate controls for timely and accurate financial data dissemination, potentially violating reporting deadlines and leading to penalties. Another incorrect approach is to solely use real-time stream processing without any form of batch aggregation or historical data integration. While this might meet latency for individual events, it would struggle with generating comprehensive reports that require historical context or complex aggregations across large datasets. This could lead to incomplete or inaccurate financial summaries, which is a significant regulatory and ethical failure in financial reporting. A third incorrect approach is to over-optimize for raw speed by skipping essential data validation and cleansing steps in the initial stages. This would compromise data integrity, leading to inaccurate financial reports. The regulatory and ethical implications are severe, as financial reports must be accurate and reliable. This approach would likely result in significant data quality issues and subsequent regulatory scrutiny. Professional reasoning. Professionals should approach process optimization by first thoroughly understanding the business and regulatory requirements, particularly latency targets and data accuracy mandates. This involves identifying critical data flows and their downstream dependencies. A phased approach, starting with understanding the data characteristics, volume, velocity, variety, and then evaluating different processing paradigms, stream, batch, microbatch, in memory, is essential. The decision-making process should prioritize solutions that offer a balance between performance and reliability, with a strong emphasis on data governance, auditability, and compliance. Continuous monitoring and performance tuning are also critical to adapt to changing data patterns and system loads, ensuring sustained compliance and operational efficiency. Question 4. Analysis of a data engineering team's strategy for improving the performance of a large-scale, multi-stage data processing pipeline that ingests and transforms terabytes of data daily for analytical reporting. The team is considering several approaches to enhance throughput and reduce latency. Option A. Prioritize the reduction of processing time by implementing aggressive data compression techniques and parallelization, even if it introduces a slight increase in data transformation complexity and potential for minor data discrepancies. Option B. Immediately deploy a new, unproven data processing framework across all pipeline stages based on industry buzz, without prior testing or performance baselining. Option C. Conduct thorough performance profiling to identify specific bottlenecks, then implement incremental, targeted optimizations based on empirical data, followed by rigorous validation of data integrity and downstream impact. Option D. Apply a generic set of performance tuning parameters to all components of the pipeline, assuming a uniform benefit across all stages, and deferring data validation until after deployment. The correct answer is C. Conduct thorough performance profiling to identify specific bottlenecks, then implement incremental, targeted optimizations based on empirical data, followed by rigorous validation of data integrity and downstream impact. Explanation. Scenario analysis. This scenario presents a common challenge in big data engineering, optimizing a complex data processing pipeline for performance and cost efficiency. The challenge lies in balancing the need for rapid data ingestion and transformation with the constraints of available resources and potential impact on downstream analytics. A hasty optimization without a thorough understanding of dependencies and potential side effects can lead to incorrect results, increased operational costs, or even system instability. Professional judgment is required to select an optimization strategy that aligns with business objectives and technical feasibility. Correct approach analysis. The correct approach involves a phased, data-driven methodology. It begins with establishing baseline performance metrics and identifying specific bottlenecks through profiling tools. This is followed by targeted experimentation with different optimization techniques, such as adjusting data partitioning strategies, optimizing query execution plans, or leveraging appropriate indexing. Crucially, each change is validated against the baseline and tested for its impact on data integrity and downstream processes. This iterative, evidence-based approach ensures that optimizations are effective, sustainable, and do not introduce unintended consequences. This aligns with professional best practices for system design and maintenance, emphasizing robustness and reliability. Incorrect approaches analysis. Implementing a broad, untested optimization strategy across the entire pipeline without prior profiling is professionally unsound. This approach risks introducing errors or performance degradations in areas that were not problematic, leading to wasted effort and potential data corruption. It bypasses the critical step of identifying actual bottlenecks, making it a shot in the dark. Applying a solution based solely on anecdotal evidence or a competitor's implementation without considering the specific architecture and data characteristics of the current system is also a failure. This ignores the unique context of the big data environment and can lead to suboptimal or even detrimental outcomes. It demonstrates a lack of critical thinking and a reliance on external, potentially irrelevant information. Focusing exclusively on reducing processing time without considering the impact on data accuracy or the cost of the chosen optimization technique is another flawed strategy. Optimization is a multifaceted goal. Neglecting data integrity or cost-effectiveness can lead to a system that is fast but unreliable or prohibitively expensive to operate, failing to meet the overall business requirements. Professional reasoning. Professionals should approach process optimization by first understanding the current state through comprehensive monitoring and profiling. This allows for the identification of specific pain points. Next, a hypothesis-driven approach to testing potential solutions is essential, where each change is small, measurable, and reversible. Validation against clear performance indicators and data quality checks is paramount. Finally, a cost-benefit analysis should inform the decision-making process, ensuring that optimizations deliver tangible value without compromising system integrity or introducing undue financial burden. Question 5. The performance metrics show that a critical data processing pipeline is experiencing significant latency, impacting downstream analytics and reporting. The team needs to optimize this process without compromising data integrity or auditability. Which of the following strategies best addresses this challenge? Option A. Immediately apply aggressive data compression techniques across all datasets within the pipeline to reduce storage and I/O overhead, assuming this will universally improve performance. Option B. Introduce significant architectural changes to the data flow without prior impact analysis or rollback planning, based on anecdotal evidence of similar optimizations in other systems. Option C. Implement a phased approach to optimization, starting with profiling to identify specific bottlenecks, establishing a performance baseline, and then making incremental, reversible changes with thorough testing at each stage. Option D. Disable detailed logging for the processing steps to reduce the overhead associated with writing logs, thereby speeding up execution. The correct answer is C. Implement a phased approach to optimization, starting with profiling to identify specific bottlenecks, establishing a performance baseline, and then making incremental, reversible changes with thorough testing at each stage. Explanation. This scenario presents a common challenge in big data engineering, optimizing process performance while adhering to strict data governance and regulatory compliance. The professional challenge lies in balancing the need for speed and efficiency with the imperative to maintain data integrity, security, and auditability, all within the context of IBM big data engineer responsibilities. Careful judgment is required to select an optimization strategy that not only improves performance, but also upholds the organization's commitment to responsible data handling. The correct approach represents best professional practice because it prioritizes a systematic, data-driven, and compliant method for performance tuning. By first establishing a baseline, identifying bottlenecks through profiling, and then implementing targeted, reversible changes, engineers ensure that optimizations are effective, measurable, and do not introduce unintended negative consequences. This methodical process aligns with industry best practices for system reliability and maintainability, and implicitly supports regulatory requirements for data accuracy and system integrity by minimizing the risk of introducing errors or data loss during optimization. An incorrect approach that involves immediately implementing aggressive data compression without understanding its impact on query performance or data accessibility would be professionally unacceptable. This could lead to regulatory failures if the compression method results in data degradation or makes data unreadable for audit purposes, violating principles of data retention and accessibility. Another incorrect approach, such as disabling logging to reduce overhead, would be a significant ethical and regulatory failure. It directly undermines auditability and traceability, making it impossible to investigate data anomalies or security incidents, which is a critical requirement for many data governance frameworks. Furthermore, making undocumented changes to the data processing pipeline, even with good intentions for performance, is professionally unsound. It creates a lack of transparency and makes troubleshooting and future modifications extremely difficult, potentially leading to system instability and non-compliance with change management protocols. Professionals should employ a decision-making framework that begins with understanding the business and technical objectives. This is followed by a thorough assessment of the current state, including performance baselines and potential bottlenecks. Next, potential solutions are evaluated not only for their performance impact, but also for their compliance with data governance policies, security standards, and relevant regulations. Implementation should be done in a controlled manner, with thorough testing and rollback plans. Continuous monitoring and re-evaluation are crucial to ensure sustained performance and compliance. Question 6. Operational review demonstrates a significant slowdown in the processing of large datasets within the IBM big data environment, impacting downstream analytics and reporting timelines. The engineering team is under pressure to quickly resolve this performance degradation. Which of the following approaches best addresses this challenge while adhering to professional best practices for IBM big data solutions? Option A. Conduct a comprehensive performance analysis of the entire data pipeline, examining query execution plans, data partitioning strategies, resource allocation, and the efficiency of data transformation jobs, aligning findings with IBM's recommended configurations for the specific technologies in use. Option B. Implement aggressive data compression techniques across all datasets without prior analysis of their impact on read/write performance and query complexity. Option C. Immediately scale up the underlying hardware resources for all components of the big data cluster, assuming that increased capacity will resolve the performance issues. Option D. Modify the data ingestion process to bypass intermediate staging tables and directly load data into the final analytical store to reduce latency. Correct answer is A. Conduct a comprehensive performance analysis of the entire data pipeline, examining query execution plans, data partitioning strategies, resource allocation, and the efficiency of data transformation jobs, aligning findings with IBM's recommended configurations for the specific technologies in use. Explanation. Scenario analysis. This scenario presents a common challenge in big data environments, balancing the need for rapid data processing with the imperative to maintain data integrity and adhere to evolving regulatory requirements. The professional challenge lies in identifying the root cause of performance degradation without compromising the accuracy or compliance of the data pipeline. A hasty optimization without understanding the underlying issues could lead to incorrect data, missed regulatory deadlines, or even data breaches, all of which carry significant financial and reputational risks. The pressure to deliver results quickly can obscure the need for a systematic and compliant approach. Correct approach analysis. The correct approach involves a methodical investigation of the data processing pipeline, focusing on identifying bottlenecks and inefficiencies. This includes analyzing query performance, data ingestion patterns, resource utilization, and the effectiveness of data transformation logic. Crucially, this approach must be conducted with an awareness of IBM's best practices for big data engineering and any relevant IBM-specific guidelines or certifications that might inform optimal configurations and performance tuning. For example, understanding how specific IBM technologies within the big data ecosystem, like DB2 Big SQL, IBM Spectrum Scale, or IBM Cloud Pak for Data, handle data partitioning, indexing, and query optimization is paramount. Adhering to these IBM-centric best practices ensures that optimizations are not only effective, but also sustainable and aligned with the platform's intended use and capabilities, thereby maximizing efficiency and minimizing the risk of introducing new issues. Incorrect approaches analysis. Implementing a broad, untested optimization strategy without a thorough diagnostic phase is a significant regulatory and ethical failure. For instance, indiscriminately increasing hardware resources without identifying the specific performance bottleneck is wasteful and does not address the core issue, potentially leading to overspending and non-compliance with budget regulations. Similarly, altering data transformation logic without rigorous testing and validation risks corrupting data. This could violate data integrity regulations, such as those requiring accurate and reliable data for reporting or auditing purposes. Another failure would be to bypass established change management and testing protocols, which are often mandated by internal governance policies and external regulations to ensure system stability and data accuracy. Such actions could lead to unforeseen system failures, data loss, or non-compliance with audit trails. Professional reasoning. Professionals should adopt a structured problem-solving framework. This begins with clearly defining the problem and its impact. Next, gather relevant data and metrics to diagnose the root cause. Based on the diagnosis, formulate potential solutions, prioritizing those that align with IBM's recommended practices and the specific technologies in use. Before implementing any changes, conduct thorough testing in a non-production environment. Implement changes incrementally, with robust monitoring and rollback plans. Finally, document all changes and their outcomes for future reference and auditability. This systematic approach ensures that optimizations are effective, compliant, and professionally sound. Question 7. Research into optimizing the performance of a large-scale financial transaction processing pipeline, a critical component for regulatory reporting, has identified several potential strategies. Which strategy best balances performance gains with the imperative to maintain data integrity and regulatory compliance? Option A. Implementing aggressive data compression techniques across all data stores to reduce storage and I/O overhead, thereby speeding up data retrieval. Option B. Re-architecting the data ingestion layer to bypass intermediate processing steps and directly load raw transaction logs into the primary data warehouse. Option C. Temporarily disabling data validation checks during peak processing hours to reduce computational load and accelerate transaction ingestion. Option D. Introducing a tiered data storage solution that archives older, less frequently accessed transaction data to lower cost storage, while keeping recent, high-activity data on faster, more expensive storage. The correct answer is A. Implementing aggressive data compression techniques across all data stores to reduce storage and I/O overhead, thereby speeding up data retrieval. Explanation. This scenario presents a common challenge in big data engineering, optimizing process performance while adhering to strict data governance and regulatory compliance. The professional challenge lies in balancing the need for speed and efficiency with the imperative to maintain data integrity, security, and auditability, especially within the context of financial data, which is subject to stringent regulations. Careful judgment is required to select optimization techniques that do not inadvertently compromise these critical aspects. The correct approach represents best professional practice, because it prioritizes a holistic view of process optimization. It involves understanding the entire data pipeline, identifying bottlenecks through systematic analysis, and then applying targeted optimizations. This method ensures that improvements are made where they have the most impact without introducing new risks. Furthermore, it emphasizes testing and validation, which are crucial for demonstrating compliance and ensuring the reliability of the optimized processes. This aligns with the principles of responsible data management and the need for auditable systems, which are often mandated by financial regulations. An incorrect approach that focuses solely on aggressive data compression without considering its impact on query performance or data accessibility would be professionally unacceptable. This could lead to regulatory issues if data becomes difficult to retrieve for audits, or if compression algorithms introduce data loss or corruption, violating data integrity requirements. Another incorrect approach, such as bypassing data validation steps to speed up ingestion, poses significant regulatory and ethical risks. It directly contravenes regulations that mandate accurate and complete data records, potentially leading to fines, reputational damage, and legal liabilities. A third incorrect approach, implementing optimizations without proper documentation or change control, undermines auditability and makes it impossible to trace the impact of changes, which is a critical failure in regulated environments. Professionals should employ a decision-making framework that begins with a thorough understanding of business requirements and regulatory obligations. This should be followed by a systematic analysis of the existing process to identify performance issues. Potential solutions should then be evaluated not only for their technical efficacy, but also for their compliance with relevant regulations, data governance policies, and ethical considerations. Prioritizing solutions that offer measurable improvements while maintaining or enhancing data integrity and security is paramount. Finally, all changes must be rigorously tested, documented, and deployed with appropriate change management procedures. Question 8. System analysis indicates a business stakeholder urgently requires access to a large dataset containing customer personal information for an immediate, high-priority marketing campaign. The stakeholder has emphasized speed and has not provided detailed information on how the data will be used beyond general marketing purposes. As the IBM Big Data engineer responsible for this data, what is the most appropriate initial course of action to balance business needs with data governance and regulatory compliance? Option A. Forward the request directly to senior management without any initial investigation, stating that the request involves sensitive customer data and requires executive approval. Option B. Refuse access to the dataset entirely, citing potential risks, and suggest the stakeholder find alternative, less sensitive data sources. Option C. Immediately grant the stakeholder access to the raw dataset, assuming they will handle it responsibly, and inform them of general data usage policies. Option D. Conduct a thorough assessment of the data's sensitivity, consult relevant data privacy regulations and internal policies, and engage with the stakeholder to understand the specific use case and explore anonymization or pseudonymization options before granting access. The correct answer is C. Immediately grant the stakeholder access to the raw dataset, assuming they will handle it responsibly, and inform them of general data usage policies. Explanation. Scenario analysis. This scenario presents a professional challenge where a big data engineer must balance the immediate needs of a business stakeholder with the long-term implications of data governance and compliance. The stakeholder's desire for rapid access to sensitive customer data for a new marketing campaign, without fully understanding the associated risks, creates a tension between business agility and regulatory adherence. The engineer must exercise careful judgment to avoid compromising data privacy, security, or legal obligations, which could lead to significant financial penalties and reputational damage. Correct approach analysis. The correct approach involves prioritizing a thorough understanding of the data's sensitivity, the applicable regulatory framework, e.g., GDPR if the exam implies a European context, or relevant U.S. federal/state laws if U.S. is implied, but sticking strictly to the exam's implied jurisdiction, and the necessary security and access controls before granting access. This aligns with the principle of privacy by design and security by design, which are fundamental to responsible data handling. By engaging in a risk assessment, consulting with legal and compliance teams, and implementing appropriate anonymization or pseudonymization techniques, the engineer upholds their professional duty to protect data and comply with regulations. This proactive stance ensures that business objectives are met without creating undue risk. Incorrect approach is analysis. Granting immediate access without proper vetting fails to acknowledge the potential for data misuse and breaches, directly violating principles of data protection and potentially specific articles within relevant data privacy regulations that mandate data minimization and purpose limitation. This approach disregards the need for a data protection impact assessment, DPIA, if required by law for processing sensitive data. Implementing a blanket anonymization that renders the data unusable for the intended marketing campaign, without exploring alternative, less intrusive methods, demonstrates a lack of problem-solving and stakeholder engagement. While appearing cautious, it fails to meet the business need and could be seen as an overreaction that hinders innovation, rather than a balanced risk mitigation strategy. Escalating the request to a higher authority without first attempting to understand the data's implications and proposing potential solutions shows a lack of initiative and technical expertise in data governance. While escalation is sometimes necessary, it should follow an initial assessment and a reasoned proposal, not serve as a primary response to a complex data access request. This approach can lead to delays and a perception of the engineering team as uncooperative. Professional reasoning. Professionals in this role should adopt a framework that begins with understanding the request and its context. This involves identifying the data involved, its sensitivity, and the intended use. Next, they must consult the relevant regulatory and internal policy landscape. A risk assessment should then be conducted, considering potential threats and vulnerabilities. Based on this assessment, appropriate technical and procedural controls should be identified and implemented. Finally, clear communication with stakeholders, including legal and compliance, is crucial to ensure alignment and informed decision-making. This iterative process of assessment, control, and communication ensures that data is handled responsibly and ethically. Question 9. The assessment process reveals that the IBM Big Data platform being developed for a financial services client needs to ingest and analyze large volumes of customer transaction data. The client has expressed urgency in gaining insights from this data to detect fraudulent activities. However, the data contains personally identifiable information, PI, and sensitive financial details. The engineering team is debating the most critical initial step to ensure both rapid insight generation and regulatory compliance. Which of the following approaches best balances the client's need for timely insights with the imperative to protect sensitive customer data and adhere to data protection regulations? Option A. Prioritize the immediate ingestion of all raw transaction data into the data lake, with a plan to address data anonymization and access controls in a subsequent phase once initial fraud detection models are operational. Option B. Implement a robust data governance framework from the outset, including data classification, anonymization/pseudonymization techniques for PII, and strict role-based access controls, before commencing large-scale data ingestion for analytics. Option C. Expedite the development of data pipelines to ingest data as quickly as possible, relying on the client's existing general-purpose security measures to safeguard the data, and deferring specific data privacy assessments until after the platform is deployed. Option D. Focus on building advanced machine learning models for fraud detection first, assuming that the raw data will be secured through network-level encryption during transit and at rest, and that detailed data privacy measures can be retrofitted later. The correct answer is A. Prioritize the immediate ingestion of all raw transaction data into the data lake, with a plan to address data anonymization and access controls in a subsequent phase once initial fraud detection models are operational. Explanation. The assessment process reveals a common challenge in big data projects, balancing the need for rapid data ingestion and processing with the stringent requirements for data privacy and security. This scenario is professionally challenging because the project team is under pressure to deliver a functional analytics platform, but any misstep in handling sensitive customer data could lead to significant regulatory penalties, reputational damage, and loss of customer trust. Careful judgment is required to ensure that the technical implementation aligns with legal obligations. The correct approach represents best professional practice because it prioritizes a comprehensive data governance framework that is integrated into the big data architecture from the outset. This includes implementing robust data anonymization and pseudonymization techniques, establishing clear data access controls, and ensuring compliance with data retention policies. This proactive stance aligns with the principles of privacy by design and by default, which are fundamental to regulations like GDPR, General Data Protection Regulation. If this were a European context, or similar data protection laws in other jurisdictions. For the C2090-101 IBM Big Data Engineer exam, this implies understanding how IBM's big data technologies can be configured and utilized to enforce these governance principles, ensuring that data is processed and stored in a manner that minimizes risk and adheres to legal mandates. An incorrect approach that focuses solely on technical performance without adequate consideration for data privacy would represent a significant regulatory and ethical failure. For instance, ingesting raw, identifiable customer data directly into a data lake without implementing appropriate masking or encryption would violate data protection laws, leading to potential fines and legal action. Another incorrect approach, such as neglecting to establish clear data lineage and audit trails, would hinder the ability to demonstrate compliance during an audit and would make it impossible to track data usage, thereby increasing the risk of unauthorized access or misuse. Furthermore, a failure to obtain necessary consents for data processing, where applicable, would be a direct ethical and legal breach. Professionals should adopt a decision-making framework that begins with a thorough understanding of the applicable regulatory landscape relevant to the data being handled. This should be followed by a risk assessment to identify potential vulnerabilities in the data processing pipeline. The technical design and implementation should then be guided by these insights, incorporating privacy and security controls as core requirements, not as afterthoughts. Regular reviews and audits of the data governance framework and its implementation are crucial to ensure ongoing compliance and to adapt to evolving regulations and threats. Question 10. Which approach would be most effective for a big data engineer to ensure that a new customer analytics data pipeline adheres to data governance principles and relevant U.S. data privacy regulations while meeting business stakeholder demands for timely insights? Option A. Proactively integrate data cataloging, lineage tracking, and granular access control mechanisms into the data pipeline's architecture from the initial design phase. Ensuring compliance is a foundational element. Option B. Implement the data pipeline for maximum technical performance and scalability first, and address data governance and compliance requirements in a subsequent phase after initial deployment. Option C. Develop the data pipeline based on technical feasibility alone, assuming that any data governance or privacy concerns can be resolved through ad hoc adjustments as needed by the business team. Option D. Focus exclusively on meeting the business stakeholders' immediate requests for data access and insights, deferring any data privacy or security considerations until a specific compliance issue arises. The correct answer is A. Proactively integrate data cataloging, lineage tracking, and granular access control mechanisms into the data pipeline's architecture from the initial design phase. Ensuring compliance is a foundational element. Explanation. Scenario analysis. This scenario presents a common challenge in data engineering projects, balancing the need for rapid development and deployment with the imperative to adhere to data governance and privacy regulations. Stakeholders, particularly business units, often prioritize speed to market and immediate insights, which can lead to pressure to bypass or shortcut established data handling protocols. The data engineer must navigate these competing demands, ensuring that technical solutions are not only efficient but also compliant and secure, thereby protecting the organization from legal repercussions and reputational damage. The challenge lies in translating abstract regulatory requirements into concrete technical implementations and communicating their importance effectively to non-technical stakeholders. Correct approach analysis. The correct approach emphasizes a proactive and integrated strategy for data governance and compliance. By embedding data cataloging, lineage tracking, and access control mechanisms directly into the data pipeline design from the outset, the data engineer ensures that regulatory requirements are met as a fundamental aspect of the system, rather than an afterthought. This aligns with the principles of privacy by design and security by design, which are increasingly mandated by data protection regulations. For instance, in the U.S., frameworks like HIPAA for health data and GDPR, though an EU regulation. Its principles influence US practices and are often considered in global operations, necessitate robust data handling practices. Implementing these controls early minimizes the risk of non-compliance, reduces the cost of remediation, and builds trust with stakeholders by demonstrating a commitment to responsible data stewardship. This approach fosters a culture of compliance and ensures that the data assets are managed ethically and legally throughout their lifecycle. Incorrect approaches analysis. Implementing data governance and compliance measures only after the data pipeline is operational and issues arise represents a reactive and inefficient strategy. This approach is highly susceptible to regulatory failures. For example, if sensitive data is inadvertently exposed or mishandled due to a lack of upfront controls, the organization could face significant fines and legal action under various data protection laws. This failure to integrate compliance from the start demonstrates a disregard for due diligence and a lack of understanding of the potential legal and ethical ramifications of data mismanagement. Focusing solely on the technical performance and scalability of the data pipeline without considering data privacy and security is another critical failure. This overlooks the fundamental obligation to protect data subjects' rights and organizational assets. Such an approach could lead to breaches of confidentiality, integrity, and availability, violating principles enshrined in data protection legislation. Ethically, it represents a dereliction of duty to safeguard sensitive information. Prioritizing stakeholder requests for immediate data access without proper validation or anonymization, even if technically feasible, poses a significant risk. This can lead to unauthorized access to sensitive information, violating privacy regulations, and potentially exposing individuals to identity theft or other harms. This demonstrates a failure to uphold the principle of least privilege and data minimization, which are core tenets of responsible data handling. Professional reasoning. Professionals should adopt a risk-based and compliance-first mindset when designing and implementing data solutions. This involves thoroughly understanding the relevant regulatory landscape, e.g., U.S. federal and state data privacy laws, industry-specific regulations, and integrating compliance requirements into every stage of the data lifecycle. A robust decision-making process includes 1. Identifying all applicable regulations and their specific requirements for data handling, storage, and access. 2. Conducting a thorough data classification to understand the sensitivity of the data being processed. 3. Designing data pipelines with built-in controls for access management, encryption, auditing, and data masking/anonymization where appropriate. 4. Engaging with legal and compliance teams early and often to validate the design and implementation. 5. Establishing clear data governance policies and procedures and ensuring they are communicated and enforced. 6. Regularly reviewing and updating data handling practices to adapt to evolving regulations and threats. Question 11. The review process indicates that a critical new business initiative requires the immediate ingestion of a large volume of external data. However, preliminary analysis suggests this data may not fully conform to the organization's established data quality standards and could potentially introduce compliance risks related to data privacy. The big data engineer is tasked with finding a solution that enables rapid deployment while mitigating these risks. Which of the following approaches best addresses this scenario from a professional and regulatory compliance perspective? Option A. Proceed with direct ingestion of all data into the production environment to meet the immediate business deadline, assuming that downstream processes will eventually identify and correct any anomalies. Option B. Implement a phased ingestion strategy, starting with a subset of the data, accompanied by a robust data validation and monitoring framework to identify and address any quality or compliance issues before full-scale deployment. Option C. Ingest the data into a separate, isolated sandbox environment for initial analysis and cleansing, without establishing clear pathways for its integration into the production environment or defining ongoing governance. Option D. Halt the ingestion process entirely until the external data source can be completely remediated to perfectly match all internal data quality standards, even if this significantly delays the business initiative. The correct answer is B. Implement a phased ingestion strategy, starting with a subset of the data, accompanied by a robust data validation and monitoring framework to identify and address any quality or compliance issues before full-scale deployment. Explanation: the review process indicates a potential conflict between the need for rapid data ingestion for a critical business initiative and the established data governance policies designed to ensure data quality and compliance. This scenario is professionally challenging because it pits immediate business needs against long-term data integrity and regulatory adherence. A big data engineer must balance these competing demands, understanding that shortcuts can lead to significant downstream issues, including regulatory penalties, inaccurate reporting, and erosion of trust. The correct approach, which involves a thorough impact assessment and a phased rollout with robust monitoring, represents best professional practice because it prioritizes a controlled and compliant integration of new data sources. This aligns with the principles of responsible data management, which are often implicitly or explicitly mandated by regulatory frameworks governing data handling and privacy. By performing an impact assessment, the engineer ensures that the new data does not violate existing data quality standards, security protocols, or privacy regulations. A phased rollout allows for early detection and mitigation of issues, minimizing the risk of widespread data corruption or compliance breaches. Continuous monitoring provides ongoing assurance that the data remains fit for purpose and compliant. This methodical approach safeguards the organization against potential legal repercussions, reputational damage, and operational inefficiencies that could arise from poorly integrated data. An incorrect approach that bypasses established data quality checks and directly ingests data into production systems represents a significant regulatory and ethical failure. Such an action could violate data privacy regulations, e.g., if sensitive data is ingested without proper anonymization or consent mechanisms, and data integrity standards, leading to inaccurate business intelligence and potentially fraudulent reporting. Another incorrect approach, which involves delaying the ingestion indefinitely due to minor policy deviations without exploring mitigation strategies, is also professionally unacceptable. This failure to adapt and innovate can stifle business growth and lead to missed opportunities, demonstrating a lack of proactive problem-solving and an inability to balance risk with reward. It can also be seen as a failure to uphold the organization's strategic objectives. Professionals should employ a decision-making framework that begins with a clear understanding of the business objective and the associated data requirements. This should be followed by a comprehensive review of existing policies, regulations, and technical constraints. The next step involves identifying potential risks and developing mitigation strategies. When faced with a conflict, the professional should explore all feasible options, prioritizing those that maintain compliance and data integrity while still enabling the business objective. This often involves seeking stakeholder consensus and documenting all decisions and their justifications. The process should be iterative, allowing for adjustments based on new information or evolving circumstances. Question 12. The analysis reveals that a critical business initiative requires the rapid ingestion and processing of large volumes of customer data for immediate market analysis. The project timeline is extremely aggressive, and there is significant pressure from stakeholders to deliver insights within days. As an IBM big data engineer operating within the United States regulatory framework, which approach best balances the need for speed with the imperative of data integrity and compliance? Option A. Temporarily bypass established data governance protocols and standard validation procedures to accelerate the ingestion process, with a commitment to re-implementing them once the initial deadline is met. Option B. Prioritize ingesting all available data as quickly as possible, with a plan to address data quality and validation issues in subsequent phases after initial insights are delivered. Option C. Rely on downstream reporting tools and application-level checks to identify and flag any data quality or compliance anomalies after the data has been processed. Option D. Implement automated data validation checks at the point of ingestion, establish clear data lineage, and ensure all transformations are auditable, even if this requires a slightly more deliberate initial pipeline setup. The correct answer is D. Implement automated data validation checks at the point of ingestion, establish clear data lineage, and ensure all transformations are auditable, even if this requires a slightly more deliberate initial pipeline setup. Explanation: scenario analysis. This scenario presents a common challenge in big data engineering, balancing the need for rapid data ingestion and processing with the imperative to maintain data integrity and comply with evolving regulatory requirements. The pressure to deliver insights quickly can lead to shortcuts that, while seemingly efficient in the short term, can have significant long-term consequences, including regulatory penalties, loss of stakeholder trust, and compromised data quality. The professional challenge lies in advocating for robust, compliant processes within a fast-paced environment, requiring strong communication and a deep understanding of both technical capabilities and legal obligations. Correct approach analysis. The correct approach involves a proactive and systematic integration of data governance and compliance checks into the data pipeline design. This means establishing clear data lineage, implementing robust data validation rules at ingestion points, and ensuring that all data transformations are auditable. For a US-based IBM big data engineer, this aligns with principles of data stewardship and compliance with regulations like the Health Insurance Portability and Accountability Act, HIPAA, if dealing with protected health information, or the Gramm-Leach-Bliley Act, GLBA, for financial data. The emphasis on automated validation and audit trails directly supports the need for demonstrable compliance and data integrity, which are cornerstones of U.S. data protection laws and industry best practices. This approach prioritizes building a foundation of trust and reliability in the data, which is essential for any critical business decision-making. Incorrect approaches analysis. One incorrect approach involves prioritizing speed of ingestion over immediate validation, with the intention of cleaning data later. This is a significant regulatory and ethical failure. In the U.S., regulations often mandate that data be accurate and protected from the point of collection. Delaying validation can lead to the propagation of inaccurate or sensitive data, which could result in violations of data privacy laws, e.g., CCPA in California or industry-specific regulations. It also erodes stakeholder confidence, as they cannot rely on the data's accuracy. Another incorrect approach is to rely solely on downstream applications to flag data quality issues. This is professionally unacceptable because it abdicates responsibility for data integrity at the source. U.S. data protection frameworks emphasize a privacy by design and security by design philosophy, meaning that compliance and quality should be built into systems from the outset, not bolted on as an afterthought. This approach creates a reactive rather than proactive stance, increasing the risk of undetected errors and potential breaches. Third incorrect approach is to bypass established data governance protocols for expediency. This is a direct violation of internal policies and potentially external regulations. U.S. regulatory bodies often require organizations to have documented data governance frameworks. Ignoring these protocols not only increases the risk of noncompliance, but also undermines the established processes designed to ensure data security, privacy, and accuracy, leading to potential legal liabilities and reputational damage. Professional reasoning. Professionals should adopt a compliance by design mindset. This involves understanding the relevant U.S. regulatory landscape, e.g., data privacy laws, industry-specific regulations, and integrating these requirements into the initial design of data pipelines. A structured approach includes 1. Understanding data sensitivity and regulatory context. Identify the types of data being handled and the specific U.S. regulations that apply. 2. Implementing robust data validation at ingestion. Design pipelines to validate data against predefined rules as early as possible. 3. Establishing clear data lineage and audit trails. Ensure that the origin and transformations of data are meticulously recorded for accountability and troubleshooting. 4. Collaborating with legal and compliance teams. Engage with subject matter experts to ensure all technical solutions meet regulatory requirements. 5. Prioritizing data quality and integrity. Advocate for processes that ensure data accuracy and reliability, even if it requires a slightly longer initial setup time. Question 13. Benchmark analysis indicates that a key business unit requires immediate access to a newly identified external dataset for critical market analysis. The data engineer has received the raw data files, but has not yet had the opportunity to perform comprehensive data quality checks, schema validation, or integration testing with existing data pipelines. The business unit lead is pressing for direct access to the data within the hour to inform an urgent strategic decision. What is the most professional and responsible approach for the data engineer to take in this situation? Option A. Provide the business unit with direct access to the raw data files and instruct them to perform their own validation before use. Option B. Perform a rapid, targeted validation of the most critical data fields and schema elements, document any known limitations, and provide access to this partially validated dataset with clear caveats, while initiating the full validation process in parallel. Option C. Refuse to provide access until a full suite of data quality and integration tests has been completed, which could take several days, without offering any interim solution. Option D. Immediately ingest the data into the production data lake, providing the business unit with direct access, and inform them that the data is new and may require further validation. The correct answer is D. Immediately ingest the data into the production data lake, providing the business unit with direct access, and inform them that the data is new and may require further validation. Explanation. Scenario analysis. This scenario presents a common challenge in big data projects, balancing the need for rapid deployment of new features with the imperative to maintain data integrity and comply with evolving regulatory requirements. The stakeholders' demand for immediate access to a new dataset without a thorough impact assessment creates a tension between business agility and risk management. A data engineer must navigate this by understanding the potential downstream consequences of introducing unvalidated data into production systems, which could affect reporting, analytics, and even operational processes. The pressure to deliver quickly can lead to shortcuts that compromise quality and compliance. Correct approach analysis. The correct approach prioritizes a structured, risk-aware process for data integration. This involves a comprehensive validation and testing phase before the data is made available to all stakeholders. This aligns with best practices in data governance and quality management, which are implicitly supported by regulatory frameworks emphasizing data accuracy and reliability. By performing thorough checks, the data engineer ensures that the new dataset meets predefined quality standards, is free from anomalies that could skew analyses, and is properly documented. This proactive stance minimizes the risk of data-related errors propagating through the organization and potentially leading to non-compliance with data privacy or reporting regulations. It demonstrates professional responsibility by safeguarding the integrity of the data ecosystem. Incorrect approach is analysis. One incorrect approach involves immediately ingesting the data into the production environment without any validation. This is professionally unacceptable because it bypasses essential quality control measures. It creates a high risk of introducing erroneous or incomplete data, which can lead to flawed business decisions, inaccurate reporting, and potential breaches of data governance policies. Ethically, it fails to uphold the duty of care to ensure data reliability. Another incorrect approach is to provide direct access to the raw, unvalidated data to the requesting stakeholder while acknowledging its unverified status. While seemingly responsive, this still exposes the organization to risks. The stakeholder might inadvertently use this data for critical decision-making, leading to the same negative consequences as direct ingestion into production. It also shifts the burden of validation onto the end user, which is not a sustainable or responsible data management practice. A third incorrect approach is to delay the integration indefinitely due to the perceived complexity of the request, without clear communication or a defined plan. This is professionally inefficient and can damage stakeholder relationships. While caution is necessary, an indefinite delay without a path forward is not a solution and fails to meet the business's evolving needs. It suggests a lack of proactive problem solving and an inability to manage project timelines effectively. Professional reasoning. Professionals should adopt a phased approach to data integration. This involves understanding the business requirement, assessing the data source and its potential impact, defining validation criteria, executing validation and testing, and finally, deploying the validated data. Clear communication with stakeholders throughout this process is crucial, managing expectations regarding timelines and the importance of quality assurance. When faced with pressure for immediate access, professionals should advocate for the necessary steps to ensure data integrity, explaining the risks associated with shortcuts and proposing a streamlined but robust validation process. Question 14. The monitoring system demonstrates a consistent pattern of unusual data values originating from a specific sensor within a large-scale EOT deployment. The data engineer suspects a potential sensor malfunction or a data ingestion issue, but the current data volume and velocity make manual inspection of individual records impractical. The engineer needs to determine the most appropriate course of action to address this anomaly while adhering to data integrity and compliance standards. Option A. Immediately initiate a data cleansing process on the affected data stream, applying statistical methods to correct the anomalous values based on historical trends and document the changes made. Option B. Escalate the anomaly to the data governance team, providing a detailed report of the observed pattern and requesting guidance on the approved remediation procedures for data quality issues. Option C. Continue monitoring the data without immediate intervention, assuming the anomaly will self-correct or is within acceptable operational variance for now. Option D. Temporarily disable the sensor to prevent further anomalous data from entering the system and await further instructions from the operations team. The correct answer is A. Immediately initiate a data cleansing process on the affected data stream, applying statistical methods to correct the anomalous values based on historical trends and document the changes made. Explanation: this scenario presents a professional challenge because it requires balancing the immediate need for data insights with the long-term implications of data governance and compliance. The challenge lies in identifying and mitigating potential risks associated with data access and usage, particularly when dealing with sensitive information. Careful judgment is required to ensure that all actions align with established regulatory frameworks and ethical considerations. The correct approach represents best professional practice because it prioritizes a structured and compliant method for addressing data anomalies. By involving the data governance team and adhering to established protocols for data quality and integrity, the engineer ensures that any remediation efforts are documented, auditable, and aligned with the organization's policies. This proactive engagement with governance bodies is crucial for maintaining data trustworthiness and meeting regulatory obligations, such as those outlined in data protection laws that mandate responsible data handling and security. An incorrect approach that involves directly modifying the data without proper authorization or documentation fails to adhere to data governance principles. This can lead to a loss of data integrity, making it difficult to trace the origin of issues or to prove compliance during audits. Such actions could violate regulations that require data accuracy and accountability, potentially resulting in penalties. Another incorrect approach, which is to ignore the anomaly if it doesn't immediately impact critical business functions, represents a significant ethical and regulatory failure. This demonstrates a lack of diligence and a disregard for data quality, which can have cascading negative effects on downstream processes and decision-making. It also contravenes regulatory requirements that often mandate proactive identification and resolution of data issues to prevent harm or misrepresentation. The professional reasoning process for similar situations should involve a clear understanding of the organization's data governance policies and relevant regulatory requirements. When an anomaly is detected, the first step should be to assess its potential impact. If the impact is significant or involves sensitive data, escalation to the data governance team and adherence to established incident response procedures are paramount. This ensures that all actions are transparent, justifiable, and compliant with legal and ethical standards. Question 15. During the evaluation of a new streaming analytics platform for processing sensitive customer financial data, the big data engineer discovers that the platform's default configuration does not fully align with the company's internal data anonymization policies, which are designed to comply with U.S. financial data regulations. The engineer is under pressure to deploy the solution quickly to meet a critical business deadline. Which approach best reflects professional decision-making in this context? Option A. Implement the platform with the default configuration and assume that the data is sufficiently protected by existing network security measures, deferring any policy review until after the initial deployment. Option B. Develop a custom anonymization script to run in parallel with the streaming data, without consulting the vendor or internal compliance, to ensure data is anonymized before it is processed by the platform. Option C. Halt the deployment and immediately engage with the platform vendor and internal legal and compliance teams to understand the feasibility and timeline for customizing the platform to meet the company's anonymization requirements before proceeding. Option D. Proceed with the deployment using the default configuration, documenting the deviation from internal policies and planning to address the anonymization gap in a subsequent patch, prioritizing the business deadline. The correct answer is D. Proceed with the deployment using the default configuration, documenting the deviation from internal policies and planning to address the anonymization gap in a subsequent patch, prioritizing the business deadline. Explanation: this scenario presents a professional challenge due to the inherent tension between the need for rapid data processing and the imperative to adhere to data governance and privacy regulations. The big data engineer must balance the technical feasibility of implementing a solution with the legal and ethical obligations surrounding data handling. The IBM Big Data Engineer certification, C2090-101, implies a focus on U.S. regulatory frameworks, particularly those concerning data privacy and security, such as HIPAA for health data or general data protection principles applicable to sensitive information. The correct approach represents best professional practice because it prioritizes compliance with established data governance policies and relevant regulations before proceeding with implementation. This proactive stance minimizes the risk of data breaches, unauthorized access, and subsequent legal penalties or reputational damage. It demonstrates a commitment to responsible data stewardship, a core tenet of professional conduct in the data engineering field. Adhering to a documented decision-making framework ensures consistency and auditability. An incorrect approach that bypasses established data governance protocols for speed would represent a significant regulatory and ethical failure. Specifically, it could violate principles of data minimization, purpose limitation, and security by design, which are foundational to many data protection laws. Such an approach risks exposing sensitive data, leading to potential fines, lawsuits, and loss of customer trust. Another incorrect approach that relies solely on technical feasibility without considering the broader impact on data integrity and compliance would also be professionally unacceptable, as it neglects the critical non-technical aspects of data management. Professionals should employ a decision-making framework that begins with understanding the data's sensitivity and the applicable regulatory landscape. This involves consulting with legal and compliance teams, reviewing existing data governance policies, and conducting a thorough risk assessment. The framework should then guide the selection of technologies and methodologies that not only meet performance requirements, but also ensure data security, privacy, and compliance throughout the data lifecycle. Prioritizing a phased approach with clear checkpoints for regulatory review is crucial. Question 16. Process analysis reveals that a critical analytics dashboard, designed to provide key performance indicators for regulatory reporting, is nearing its deployment deadline. During final testing, a junior engineer identifies potential inconsistencies in the underlying data that could lead to inaccurate reporting. The project manager is pushing for immediate deployment to meet the deadline, citing market pressure. The data quality issues, if unaddressed, could violate specific data integrity regulations relevant to financial reporting. Which of the following actions represents the most professional and compliant approach for the big data engineer? Option A. Immediately halt the deployment of the dashboard and escalate the data quality concerns to the data governance team and the compliance officer for thorough investigation and remediation before proceeding. Option B. Inform the project manager that the deadline cannot be met due to the data quality issues and refuse to participate in the deployment until the data is perfect, without further consultation. Option C. Attempt to quickly patch the data inconsistencies without involving the data governance or compliance teams, hoping to resolve the issue before it's detected. Option D. Proceed with the dashboard deployment as scheduled, documenting the data quality concerns for a post-deployment fix, and assure the project manager that the issues are minor. The correct answer is A. Immediately halt the deployment of the dashboard and escalate the data quality concerns to the data governance team and the compliance officer for thorough investigation and remediation before proceeding. Explanation: scenario analysis. This scenario presents a common challenge in big data engineering, balancing the need for rapid development and deployment of new features with the imperative to maintain data integrity and comply with evolving regulatory requirements. The pressure to deliver a new analytics dashboard quickly, coupled with the discovery of potential data quality issues that could impact regulatory reporting, creates a conflict. A hasty decision could lead to inaccurate reports, fines, and reputational damage. While an overly cautious approach might miss market opportunities, the professional challenge lies in navigating this tension by applying a structured decision-making framework that prioritizes compliance and data governance without stifling innovation. Correct approach analysis. The correct approach emphasizes a systematic, risk-based methodology. It involves immediately halting the deployment of the dashboard until the data quality issues are thoroughly investigated and remediated. This aligns with the principles of data governance and regulatory compliance, which mandate accurate and reliable data for reporting. By engaging the data governance team and the compliance officer, the engineer ensures that the remediation process is aligned with established policies and legal obligations. This proactive stance prevents the propagation of bad data, which could lead to significant regulatory penalties and a loss of trust. This approach demonstrates a commitment to ethical data handling and adherence to the spirit and letter of data protection and reporting regulations. Incorrect approach is analysis. Proceeding with the dashboard deployment without addressing the data quality issues is a direct violation of data integrity principles and regulatory mandates. This approach risks generating inaccurate reports, which can have severe legal and financial consequences, including fines and sanctions. It also undermines the credibility of the data and the organization. Ignoring the data quality issues and focusing solely on the dashboard's functionality, while promising to address the data later, is equally problematic. This fix-it-later mentality often leads to the problem being forgotten or becoming more complex to resolve. It demonstrates a lack of due diligence and a disregard for the potential downstream impacts on regulatory compliance and business decisions. Escalating the issue to senior management without first conducting a preliminary investigation and proposing potential solutions is inefficient and can overload leadership with operational details. While escalation is sometimes necessary, it should be a last resort after attempting to resolve the issue at the appropriate technical and governance levels. This approach fails to demonstrate proactive problem-solving and can be perceived as an abdication of responsibility. Professional reasoning. Professionals in big data engineering should adopt a decision-making framework that prioritizes data governance, regulatory compliance, and risk management. This framework involves 1. Problem identification and assessment. Clearly define the issue and its potential impact. 2. Information gathering. Collect all relevant data including technical details and regulatory requirements. 3. Stakeholder consultation. Engage with relevant teams, e.g., data governance, compliance, legal, to understand perspectives and obligations. 4. Option generation and evaluation. Brainstorm potential solutions and assess them against technical feasibility, regulatory adherence, and business impact. 5. Risk mitigation. Identify and plan for potential risks associated with each option. 6. Decision and implementation. Select the best course of action and execute it with clear communication. 7. Monitoring and review. Track the effectiveness of the implemented solution and make adjustments as needed. Question 17. Risk assessment procedures indicate that a large dataset containing customer demographic and behavioral information requires processing for advanced analytics, but also presents significant privacy concerns. Which of the following approaches best balances the need for analytical utility with regulatory compliance for data privacy? Option A. Apply a single, static anonymization method to the dataset and assume it will remain compliant indefinitely without further review. Option B. Implement pseudonymization techniques for sensitive data fields, coupled with strict role-based access controls and comprehensive audit logging of data access and usage. Option C. Replace all personally identifiable information, PI, with generic placeholders and aggregate the data to a high level to prevent any possibility of individual identification. Option D. Prohibit the collection and processing of any data that could be construed as sensitive, even if it limits the scope of potential analytical insights. The correct answer is B. Implement pseudonymization techniques for sensitive data fields, coupled with strict role-based access control and comprehensive audit logging of data access and usage. Explanation. Scenario analysis. This scenario presents a professional challenge related to data governance and compliance within the context of IBM big data technologies. The core difficulty lies in balancing the need for data accessibility for advanced analytics with the stringent requirements of data privacy regulations. Specifically, the challenge is to implement a data anonymization strategy that is effective enough to meet regulatory compliance without rendering the data unusable for its intended analytical purpose. This requires a nuanced understanding of both the technical capabilities of the big data platform and the legal obligations. The professional must exercise careful judgment to select an approach that is both technically sound and legally defensible. Correct approach analysis. The correct approach involves a multi-layered strategy that prioritizes data minimization and pseudonymization techniques, coupled with robust access controls and audit trails. This aligns with the principles of data protection by design and by default, as mandated by many data privacy frameworks. Pseudonymization, where direct identifiers are replaced with artificial identifiers, allows for a significant reduction in privacy risk while retaining analytical utility. Implementing strict access controls ensures that only authorized personnel can access the data, and only for legitimate purposes. Comprehensive audit trails provide accountability and facilitate compliance verification. This approach is best professional practice because it directly addresses the regulatory requirements for data protection and privacy by implementing technical and organizational measures that minimize the risk of re-identification and unauthorized access, thereby upholding ethical data handling standards. Incorrect approach is analysis. One incorrect approach is to rely solely on simple data masking techniques like replacing all personally identifiable information, PI, with generic placeholders. This is professionally unacceptable because it often renders the data too generalized for meaningful analysis, defeating the purpose of collecting and processing it. Furthermore, it may not fully satisfy regulatory requirements if the masking is not robust enough to prevent re-identification through indirect means or linkage with other datasets. Another incorrect approach is to implement a blanket ban on collecting or processing any data that could be considered sensitive. While seemingly protective, this is professionally unsound as it stifles innovation and the potential for valuable insights that could benefit the organization or its stakeholders. It fails to acknowledge that data can be processed responsibly and ethically with appropriate safeguards. A third incorrect approach is to assume that anonymization is a one-time process and not to establish ongoing monitoring and re-evaluation of the anonymization techniques. This is a significant regulatory and ethical failure. Data landscapes and analytical needs evolve, and anonymization techniques may become less effective over time due to advancements in data analysis or the availability of external data. Failing to re-evaluate risks, a breach of compliance and ethical obligations. Professional reasoning. Professionals should employ a decision-making framework that begins with a thorough understanding of the applicable regulatory landscape and the specific data being handled. This involves identifying sensitive data elements and assessing the risks associated with their collection, processing, and storage. The next step is to explore a range of technical and organizational measures for data protection, considering their effectiveness, impact on data utility, and feasibility within the big data environment. A risk-based approach is crucial, where the level of protection applied is commensurate with the level of risk. This framework emphasizes continuous assessment, adaptation, and documentation of all data handling practices to ensure ongoing compliance and ethical conduct. Question 18. Regulatory review indicates that a big data engineer is tasked with preparing a large dataset for public release containing sensitive customer information. The primary objective is to enable broad analytical use while minimizing the risk of individual re-identification. The engineer must select appropriate anonymization techniques. Which of the following approaches best balances data utility with robust privacy protection in compliance with data protection principles? Option A. Remove all direct identifiers and assume the data is sufficiently anonymized for public release. Option B. Prioritize maximizing the number of data fields available for analysis, even if it means employing only basic masking techniques. Option C. Implement pseudonymization by replacing direct identifiers with unique codes, followed by generalization of demographic attributes and suppression of rare categories to mitigate re-identification risks. Option D. Apply simple data masking to a few sensitive fields without a formal risk assessment of quasi-identifiers. The correct answer is C. Implement pseudonymization by replacing direct identifiers with unique codes, followed by generalization of demographic attributes and suppression of rare categories to mitigate re-identification risks. Explanation. Scenario analysis. This scenario presents a professional challenge where a big data engineer must balance the technical imperative of data processing efficiency with the regulatory requirement for data privacy and security. The challenge lies in identifying and implementing appropriate anonymization techniques that effectively reduce the risk of re-identification while maintaining the utility of the data for analytical purposes. The pressure to deliver timely insights can lead to shortcuts that compromise compliance, making careful judgment and a thorough understanding of relevant regulations paramount. Correct approach analysis. The correct approach involves a multi-layered strategy for data anonymization, prioritizing techniques that demonstrably reduce re-identification risk in accordance with established data protection principles. This includes employing pseudonymization, where direct identifiers are replaced with artificial identifiers, and further applying generalization or suppression for quasi-identifiers. The selection of specific techniques should be guided by a risk assessment that considers the sensitivity of the data, the intended use of the data, and the potential for re-identification given available external datasets. This approach aligns with the principle of data minimization and purpose limitation, ensuring that personal data is processed only to the extent necessary for specified purposes, and that appropriate safeguards are in place to protect individuals' rights and freedoms. Adherence to these principles is fundamental to regulatory compliance, preventing breaches and maintaining trust. Incorrect approaches analysis. One incorrect approach is to rely solely on simple data masking or truncation without a comprehensive risk assessment. This fails to address the potential for re-identification through combinations of quasi-identifiers, which can still allow individuals to be identified. This approach is a regulatory failure because it does not implement adequate technical and organizational measures to protect personal data, potentially violating data protection laws that mandate robust anonymization. Another incorrect approach is to assume that removing direct identifiers is sufficient for anonymization. This overlooks the concept of re-identification through quasi-identifiers, which are attributes that, when combined, can uniquely identify an individual. This is a significant ethical and regulatory failure, as it exposes individuals to privacy risks and contravenes the spirit and letter of data protection regulations that require a higher standard of anonymization. A third incorrect approach is to prioritize data utility over privacy protection by implementing minimal or ineffective anonymization techniques. This demonstrates a disregard for individuals' fundamental right to privacy and can lead to severe regulatory penalties, reputational damage, and loss of public trust. It represents a failure to uphold ethical responsibilities and comply with legal obligations. Professional reasoning. Professionals should adopt a decision-making framework that begins with a thorough understanding of the data being processed, its sensitivity, and the intended analytical outcomes. This should be followed by a comprehensive review of applicable data protection regulations and guidelines. A risk-based approach to anonymization is crucial, involving the identification of direct and quasi-identifiers and an assessment of re-identification risks. The selection and implementation of anonymization techniques should be documented, and their effectiveness regularly reviewed. Continuous learning and staying abreast of evolving anonymization, best practices, and regulatory interpretations are essential for maintaining compliance and ethical conduct. Question 19. The control framework reveals a new data governance policy mandating stricter access controls and anonymization for sensitive customer data. As an IBM big data engineer, you are responsible for implementing this policy within the existing big data infrastructure. Which of the following actions best aligns with professional responsibilities and regulatory compliance? Option A. Immediately implement the new policy across all data pipelines, assuming the technical feasibility is confirmed. Option B. Proceed with the technical implementation of anonymization techniques, deferring detailed review of access control requirements until after the initial deployment. Option C. Consult with the organization's legal and compliance departments to thoroughly understand the regulatory implications and ensure the implementation adheres to all applicable U.S. federal data privacy laws before proceeding. Option D. Prioritize the implementation of the policy based on which data sets are most frequently accessed by business units to minimize operational disruption. The correct answer is A. Immediately implement the new policy across all data pipelines, assuming the technical feasibility is confirmed. Explanation. This scenario presents a professional challenge because the big data engineer is tasked with implementing a new data governance policy that directly impacts the accessibility and processing of sensitive customer data. The challenge lies in balancing the need for robust data security and compliance with regulatory requirements against the operational demands of the business, which may require timely access to this data for analytics and decision-making. The engineer must navigate potential conflicts between different stakeholder needs and ensure that the chosen approach aligns with the IBM Big Data engineer's responsibilities under the relevant regulatory framework, which for this exam is assumed to be U.S. federal regulations pertaining to data privacy and security. The correct approach represents best professional practice because it prioritizes a thorough understanding of the regulatory landscape and its implications for the specific data being handled. By engaging with legal and compliance teams, the engineer ensures that the implementation adheres to all applicable laws and guidelines, such as those outlined by the relevant U.S. federal agencies governing data privacy e.g., FTC, HIPAA if applicable to the data type. This proactive engagement mitigates the risk of noncompliance, which can lead to significant fines, reputational damage, and legal repercussions. It demonstrates a commitment to ethical data handling and responsible engineering practices. An incorrect approach that involves immediately implementing the policy without consulting legal and compliance teams represents a significant regulatory and ethical failure. It bypasses the necessary checks and balances designed to ensure adherence to U.S. data privacy laws. It could lead to the accidental violation of regulations concerning data access, consent, or security, exposing the organization to legal penalties. Another incorrect approach, such as prioritizing business expediency over regulatory adherence, is also a failure. This demonstrates a disregard for the legal obligations of the organization and the privacy rights of individuals whose data is being processed. Such an approach can result in severe penalties and a loss of customer trust. Finally, an approach that focuses solely on technical implementation without considering the broader governance and compliance implications ignores the fundamental principles of responsible data management and the legal framework governing it. Professionals should employ a decision-making framework that begins with a clear understanding of the problem and its context, including all relevant regulatory requirements. This should be followed by identifying and evaluating potential solutions, considering their technical feasibility, business impact, and crucially, their compliance with all applicable laws and ethical standards. Consultation with subject matter experts, such as legal counsel and compliance officers, is a critical step in this process. The chosen solution should then be implemented with robust monitoring and auditing to ensure ongoing compliance and effectiveness. Question 20. The efficiency study reveals that a critical big data project requires immediate access to a large, sensitive dataset for development and testing. The fastest method to provide this access involves granting the development team direct, unfiltered access to the raw, identifiable data. However, this approach carries a high risk of accidental data exposure or misuse, potentially violating data privacy regulations. What is the most appropriate and compliant approach to enable the development team to proceed with their work while safeguarding sensitive data? Option A. Proceed with providing direct access to the raw, identifiable data and address any potential data privacy issues or breaches only if they occur. Option B. Grant the development team direct access to the raw, identifiable data, with a strong verbal directive to exercise extreme caution and avoid any misuse. Option C. Halt the project indefinitely until a hypothetical, perfectly secure and compliant data acquisition method can be developed, which may take an extended period. Option D. Implement robust anonymization and aggregation techniques on the dataset before providing it to the development team, ensuring that no personally identifiable information is exposed. The correct answer is D. Implement robust anonymization and aggregation techniques on the dataset before providing it to the development team, ensuring that no personally identifiable information is exposed. Explanation. Scenario analysis. This scenario presents a professional challenge rooted in the inherent tension between optimizing resource allocation for a critical project and adhering to established data governance and privacy regulations. The project's success hinges on timely access to comprehensive data, but the proposed method of data acquisition, while efficient, carries significant risks of unauthorized access and potential misuse. The need for speed must be balanced against the imperative to protect sensitive information and maintain compliance with data protection laws. This requires careful judgment to avoid compromising either project goals or legal obligations. Correct approach analysis. The correct approach involves implementing robust anonymization and aggregation techniques before data is shared with the development team. This aligns with the principles of data minimization and purpose limitation, fundamental to data protection regulations. By transforming the data into a format that no longer identifies individuals, the organization upholds its ethical and legal duty to protect privacy. This method ensures that the development team can access the necessary insights for their work without exposing personal data, thereby mitigating risks of breaches and non-compliance. This represents best professional practice as it proactively addresses potential privacy concerns and demonstrates a commitment to responsible data handling, which is a cornerstone of regulatory compliance and public trust. Incorrect approaches analysis. One incorrect approach involves granting direct access to raw, identifiable data to the development team with the assumption that they will exercise caution. This is a significant regulatory and ethical failure. It violates the principle of least privilege, which mandates that individuals should only have access to the data necessary for their specific tasks. Furthermore, it exposes the organization to severe penalties under data protection laws for failing to implement adequate security measures to prevent unauthorized access or misuse of personal data. Another incorrect approach is to delay the project indefinitely until a perfect, risk-free data acquisition method is found. While caution is warranted, an indefinite delay without exploring viable, compliant alternatives demonstrates a failure in professional problem-solving and project management. It can lead to missed business opportunities and project stagnation, and it fails to acknowledge that risk management, not absolute risk elimination, is the practical standard. A third incorrect approach is to proceed with the data acquisition without any form of consent or notification to the data subjects, even if anonymized. While anonymization reduces direct identification, a lack of transparency about data usage can still raise ethical concerns and potentially fall foul of broader data protection principles regarding fair processing and accountability, especially if the original data collection had specific consent limitations. Professional reasoning. Professionals should employ a risk-based decision-making framework. This involves identifying potential risks, e.g., data breaches, non-compliance, assessing their likelihood and impact, and then developing mitigation strategies. In data-related scenarios, this framework should prioritize compliance with relevant data protection laws and ethical considerations. When faced with a conflict between project speed and data security/privacy, the process should involve 1. Understanding the specific regulatory requirements applicable to the data. 2. Evaluating the sensitivity of the data. 3. Exploring all compliant data transformation and access methods. 4. Consulting with legal and compliance teams. 5. Documenting the decision-making process and the rationale for the chosen approach. This structured approach ensures that decisions are not only efficient, but also legally sound and ethically responsible.